Yes. You want to get in? Money. What happened? Started recording. Yeah, started recording. Fine. Silent and ಕೂತ್ಕೊಂಡ್ರೆ ಮಾತ್ರ ಇಲ್ಲ ನಿಮಗೆ ಅಷ್ಟು ಕಷ್ಟ ಆದ್ರೆ ಇಲ್ಲಿ ಬಂದ್ಬಿಡು. Okay, so now we supposed to know what are the types of the SMPS, that is converters, or SMPS you will call that one. It's a converter. It's basically a converter. It's converting AC to DC. Okay, so it's not an inverter. Don't think it's an inverter. It's a converter. AC is taking as an input, converting that one into required DC. Basically, there are 4 different types of converters are there. That is flyback SMPS, then feed forward SMPS, push pull SMPS, and bridge SMPS. These are the 4 categories which comes under SMPS. Let us see what is there in the syllabus. So we will be having switch mode, isolated flyback converter, isolated forward converter, and we don't have the bridge and we don't have the push pull. Okay, only 2. As per the syllabus, only 2 are there. We'll go for only 2. Flyback and feed forward. Forward SMPS, flyback SMPS. The schematic diagram. Actually, we have seen the photo. Inside the photo, how exactly your circuit is being designed. We will be having that one in the form in the representation of the schematic diagram. See the block diagram of this. We will be having input where actually here is the AC. AC signal comes into picture. So the entire block is having the combination of different types of electronic devices. We will be having a filter, we will be having an input rectifier and a filter, switching element, isolation power transformer, output rectifier and filter. We will be having IO isolation, feedback control, where overcurrent protection circuit, over voltage protection circuit. What happens now? I need only 12 volts. I need only 15 volts. I need only 5 volts. But the filter and rectification, whatever it is doing, initially I mean direct AC signal. When you are giving AC signal, there may be some noise. There may be some noise. We cannot predict that. So I plug, I'll just plug it over there, and then say we can give a CPU. There is SMPS. So the fluctuation, the variation in AC, because it is 230 volts, we will say 230 volts AC is coming. If the entire circuit, whatever is been built, the electrical circuit is built, everything is sophisticated, efficient, then exactly 230 volts you are going to get. Otherwise, it will be in the range of 210 to 240. 210 volts to 240 volts, so it will be fluctuating that. So we need to filter out. You have to filter out. We are supposed to say that I need to get a constant or regulated 230 volts. I should get that. For that purpose, we are going to use the filters. When your RF filters are there, RF filters, that's going to whatever the radio frequencies we are going to have, it's going to filter it out. Okay? So we'll see that in communication, and we are going to understand what it means by RF, how exactly it's going to filter it out. Here, since my AC input is maybe having some fluctuation, I need to filter it out. Once it is being filtered, my basic requirement is a DC. I need a DC. So obviously we are going to use a rectifier. A rectifier circuit we are going to use it. So rectifier what we do? AC to DC conversion. Generally, diodes we are going to use, or if we use the thyristor, we may use different types of switching elements. Then it's going to convert the pure AC into pulsating DC. Switching element, the thyristor or a transistor or any type of switching element we are going to have, it's going to switch. And for that switch it has been connected. See what are the switching elements we are having? A transistor may be there, different types of transistor, and maybe a switch also. See, there may be a transistor, there may be a MOSFET, there may be a simple switch. Any one of that one can be there here. Listen, this particular block diagram, it is representing here. It can be a transistor, it can be a MOS, simple BJT, simple MOSFET, simple switch. It can be any one of that one. So this is not the additional block. It is not the additional block which is there. It is representing this particular block. It is representing this block. What may be there? What may be there? This element. What may be there? It may be BJT. It may be MOSFET. It may be simple switch. It may be thyristor. It may be anything. Okay. So what is the functionality it is doing? This is the functionality. The functionality of that particular switch is this. This particular switch, it is protecting the overcurrent. If any overcurrent is there in the circuit, it's going to protect by using your switch. Switch is used to protect the overcurrent operation. Means nullify the overcurrent. That's what I'm saying. It's a regulated power supply should be given over there. Constant power supply. That will be taken care by your switch. Isolation power transformer is going to transform that one. It's going to, it means wherever you have to give, it's going to transform that one. What are the different types of power is required, it's going to be. And similarly, we are going to have one more device. This functionality of this one is to protect from the over voltage. Okay, this circuit, this particular element which is there in your SMPS, it will be for rectification where voltage can be reduced. Over voltage can be nullified. I need exactly 12 volts. I can take 12 volts. If any AC signal is present, ripple pattern is present, pulsating AC is there, all those can be stopped. Stabilizer is going to stabilize. Stabilizer what's going to happen? You will be at AC. Input as AC. You will be getting a constant regulated power supply. It is AC. Not DC. DC only is going. So then after that, going inside, it's going to be the DC. See, TV stabilizer, refrigerator stabilizer, refrigerator will be having stabilizer, everything will be having stabilizer. Inside the TV, we are going to have the conversion, not outside the TV. Okay, so we are not going to convert AC into DC and then into TVs. Okay, we will then do the towards AC. That will be given to the stabilizer. Stabilizer will be giving a stabilized AC output. Stabilized AC output. There should not be any fluctuation. As I said, 210 to 230 volts will be 240 volts will be. That fluctuation should not affect your refrigerator or TV or some other device. So, stabilizer is converting AC to AC, which is going to keep the constant output. No fluctuations. But here what we are having, SMPS is not a stabilizer, it is going to convert the AC signal into DC signal. So here, this is a protects the current, means overcurrent can be nullified, and this particular device, the element of the block diagram, block what they are having, it takes care of over voltage operation. Any over voltage is there, no, that is can be nullified. That can be. So we will be having isolation and also control operation. It's going to control what is the control? Feedback and control. It's going to give the feedback, any changes. It will be what is the purpose of the feedback? Repeated operation. When we want to go for the repeated operation, such a one, it's going to make it uniform. Assume I am at 5 volts initially. Give that 5 volts once again back, filter it out, perform some operation. In addition to the input, then it's going to generate 6 volts. Then give that 6 volts once again. With the input, it's going to make 7 volts. So like this, keep on feeding back. Finally, you are going to get saturated and constant voltage. Should come early, no? Please, pay. No issues. ID card ilva? Right. So simple block diagram, you suppose to explain one line or one statement saying what is the purpose of each block of that. Feedback it's mainly to control the finally to get the fine tune your data or fine tune your signal or fine tune your output. That is the feedback operation we call that. Let us see how exactly it's going to work. See here, the same thing is been explained here. Converts AC to DC voltage with rectifier. That is the actual function. Step you, last bench. One should be there in the class, other two should be shifted. Shift ಆಗಿದೆಯಾ? ಗೊತ್ತು ಒಬ್ಬರು ಬಿಟ್ಟಿರಲ್ಲ ಅಂತ ಗೊತ್ತು. But I can't help it out. Meanwhile, you also. ಈ ಕಡೆ ಬರ್ತಾ? Hello. Go there. You shift that side. Then ಈ ಕಡೆ ಬರ್ತಾ? So better be like this out in my class. Fixed. Okay. So SMPS, the basic functionality, basic operation is listed out. First and foremost is converting AC to DC. Required DC. It may convert into multiple different types of DC functions. Which is unregulated DC. Unregulated DC. Voltage sent to its filter. Inverter convert DC to AC with the help of the power oscillator. If there is an inverter is there in your SMPS, generally inverter will convert DC to AC. Output transformer inverts AC voltage up to the required output level. Transformer step down. So step down operation. Output rectifier and filter. This rectifier and filter is there. AC output from a transformer is rectified. The transformer is what is giving the AC signal, and that AC signal will be converted by the rectifier. So we convert into required DC voltage. For low voltage uses, silicon and Schottky diodes used. So there are very low voltage is required. 5 volts, 230 volts AC is there, but 5 volts DC is required. To get that 5 volts DC, I will be using some silicon related devices or Schottky devices that are going to use them. Generally, as you have seen in the lab also, if I am having a small capacitor, it will be in the form of silicon capacitor or ceramic capacitor. There are two types of capacitors are there. One is electrolytic capacitor, and one is ceramic capacitor. Electrolytic capacitor you already use, both of them you have used in the lab. One is a brown color, and bubble like that is there, two lines in there. That is a brown ceramic capacitor. It's in low value. Since the electronic capacitor what we have, blue color you won't have, where the gray band is on the side. Okay, gray band is on the side. That is electronic capacitor and high capacitance. So any low voltage required or low voltage operations are required, in general we are going to use silicon based devices. Okay, so either you can use silicon or Schottky diodes. Even your diode is silicon diode. Whatever the diode you want to use silicon, based on silicon. Silicon is soil, sand. Okay. Ceramic, all your ceramic devices are like that only. Okay. How exactly SMPS is going to work? Reduces the amount of voltage passing through the transformer. The continuation of your SMPS, AC to DC conversion and filtering and mass removal, DC to AC conversion, that is inversion, everything is going to be taken care. Any small voltage operations will be done. You are going to use the silicon based devices. Now, this also reduces the amount of voltage passing through the transformer. Amount of voltage passing through the transformer. Whatever the voltage is passing through the transformer, it is going to reduce it. So the output voltage will be maintained normally. So transformer, step down transformer, you can say 230 volts can be stepped down to 15 volts. So 15 volts constantly can be there. Once it's 15 volts, you can easily convert that to 12 volts or 5 volts easily can easily convert. That is why a simple rectifier 12 volts DC or 5 volts DC, whichever the requirement. Okay, based on the resistance, based on the load, you are able to get that. You are able to get the what type of voltage is required. Then it is sent to the output of the power supply. A sample of this output is sent back to the feedback signal for regulation. I told you what is the purpose of the feedback is. I'm adding some output I'm getting. If it is not proper, send it back once again. Send it back once again. So it's going to add with the new data. Finally, it's going to make it constant. The final fine-tuned value is going to come over. So it's like I'm having a feedback circuit. This is the feedback. I'm having input and I'm having output. This output is fed back once again here. Such a way that initially I may be getting some 5 volts. Assume, just assume. I'm randomly explaining that one. Initially I'm getting 5 volts at first step. But 5 volts is not sufficient. It's not my output. So what I will do, the same 5 volts, I will be feeding back to the circuit. In addition to that, when I'm already having the input over there, input also has been given. This first output 5 volt has been given over there. It's going to get added up, and that will go inside to the feedback once again. That will regulate. Finally, you are going to get a final output. This should be repeated. Repeatedly, you should give that one. There are so many electronic circuits you are going to work out there, which go for the loop, a loop operation. So you will come to know one saturation level and one regulated output will come. That's why we say regulated output to maintain the regulation, to maintain the constant output, which will always give the feedback operation. Okay, so now repeatedly you can keep on saying the same thing so that you go on stuck in your mind. Similarly, repeatedly you keep on feeding back to the same circuit over there. Finally, you are going to get one constant output. One constant output, that is the regulated output you are going to get. Basic topology of the flyback converter. Basic two types of converters we are supposed to discuss. One is the flyback, other is the power. Feed power. Okay. Flyback converter is one type which comes under the SMPS. Feed power converter is the other one which comes under the SMPS. The first one is flyback converter. This is the circuit diagram. It is also called as discontinuous mode. Here we have a DC signal which is being given to a transformer output. We have a diode filter. Diode is, this is the AC signal. AC signal is getting converted, stepped down to AC. The output is AC only here. It is just assume that from here to what you are looking at. See what exactly resembles. So rectifier, simple opera rectifier only. Okay, right? Opera rectifier circuit. This entire thing is opera rectifier circuit. What we have done in our lab. The transformer is having 220 volts AC, that will convert into step down AC, and the AC is being given to the diode. Diode is a DC signal. It may be having some ripple, and ripple can be removed by using the filter. This capacitor what we are having is a filter. We have added this one to the circuit also. In our circuit also we are having we keep this in our lab experiment. Okay, so but the problem here is this is called as the discontinuous mode operation. It's not a continuous mode operation, it's a discontinuous mode operation. There is one more problem here. Actually, transformer is of AC. Here we are not giving the AC signal, we are giving the DC signal. A DC signal is being given. We like a thyristor. Okay, it's a MOSFET. It's not a MOSFET we are using. It's not a thyristor, it's not a BJT. There is Transformer should be MOSFET is going to be triggered once here that's by memory items of your transformer. We are going to have discussion. Please need to be explained. Check whether it's there or not. Yeah. Playback converter is the most commonly used application. Sorry, no output power application. The output voltage needs to be isolated from the input main supply. The output power may vary from few watts to less than 100 watts. It is a transformer which is being given a DC voltage with the thyristor with the switch. Okay, let me take it as a switch instead of thyristor. I'll make it as a switch with the switch operation with the gate pulse. Transformer is triggered. It gets some input voltage that will be stepped down to some value. This is based on the number of windings we are having. Windings only will vary that one whether it's a step up or step down. Number of windings difference between the N1 and N2. Electrical, you studied this one in your first semester. N1 and N2 value. Based on N1 and N2 value, I am able to measure V1 and V2. Okay. What is the equation? V1 by V2 is equal to N by N2. V1 by V2 is equal to N by N2 or what? So it varies, depends. Means inversely proportional. It's going to be inversely proportional. You are going to get that. So this is a simple flyback converter with respect to SMPS, where it works with the discontinuous mode, where it's going to be used for low power applications, very low power applications. Which are the low power applications you are using, you can go for it. So flyback converter is the most commonly used SMPS, low output power applications. The output voltage needs to be isolated from the input main supply. This is where your concentrations need to be. Output voltage needs to be isolated. It should be separated. It should not be totally equal or dependent on the input power supply. For that purpose, we are going to use the flyback. Output power may vary from very low watts to the 100 watts. The circuit can offer single or multiple isolation output voltages, operate over wide range of input voltage variations. Any variations which are there in input voltage, it can work. In respect of energy efficiency, flyback power supplies are inferior to many other SMPS circuits with respect to energy efficiency. So it is not that much energy efficient. This flyback converters, they are not energy efficient when it comes compared with the other one. But its simple topology and low cost makes it popular in low output power. Typically efficiency is 65 to 75%. So that is why cost is very low. Simple circuit where we can easily affordable, easily used for low power circuits only. That is why we are going to use the flyback converter. Mode 1, mode 2, mode 3. Three different modes are there of this particular flyback converter. Mode 1, mode 2, mode 3. Okay, let me stop it now because modes are all the things I'm going to cover at one time. 3 different modes can be covered where that we are able to get what is the difference between all the 3 modes.